Since we have them, we can use the point as well. So if we have a point 3.8 on our exponential graph, then the 0.83 will be on our inverse, which is our logarithmic graph, okay? So all we're doing is switching the x and the y. Exponential graph, this is how you do it because your 3 would be your x, your 8 would be your y, okay? So then all we did was put 8 in for y and 3 in for x, so that's where this came in. So then the inverse, you would just switch the x and the y, so this would be your new x, this would be your new y. So your x would be 8, so 8 would be your argument. Your y would be 3, your value. Okay, does everyone see where those numbers are coming from?
The second bullet is the inverse of it?
Yeah, so this right here is the inverse, because you know that exponential and logarithmic functions are inverse and they have the same base. So we're just flipping the x and the y, so we're flipping our coordinate, and then we're just putting those values into our logarithm or exponential equation, okay? Okay, what statement can be made from the point -2, 1/4 on the graph of y equals 2 to the x? So if I have y equals 2 to the x, this would be my x value, this would be my y. So to put it in, I'll do this one with you guys. To put this one in, your y is 1/4, so 1/4 equals 2, and then your exponent would be -2. Does everyone see where I got those numbers? I'm using y equals 2 to the x. This is my x, this is my y. Y equals 2 to the x or y equals log of x base 2. So if it's saying that you're using the graph of y equals 2 to the x, you're putting your x and your y into that equation. Okay. So all you're doing is you're taking your x and your y here and putting them into your x and your y there. So if I have the point 16.4, how can I put that into log of x base 2? So this is your x. It always goes x comma y. So if your y is 4, it's going to be 4 equals. Perfect. Log of 16 base 2. Does everyone see where we're getting these numbers? Okay. If you have to do x comma y every time, I'm fine with that. Okay, that's what I do when I do this, when I make your keys. Because I have y equals 2 to the exponent x. If my x equals -2, this whole thing has to go up there. Okay, let's see if we can figure out between logarithmic and exponential form. Okay, so with logarithmic form, you know your point here would be 8, 3, right? That would be your coordinate point. Your x is your 8 and your y is 3. Is everyone okay with that? So to do the inverse, your point would be 3, 8, right? All I'm doing is switching the x and the y. So then your 8 would be your y, your 3 would be your x. Do you see where those come from? You can also just look at these two. So if I give you a logarithmic form, you could be able to do, oh, there we go. If I give you a logarithmic form, you should be able to just put, know where your number is exponential. Rael, can you hear me? Still can't. So this 8 here, so your argument goes into your y value for your exponential equation, and your value for your logarithmic will turn into your x. So you see how your argument for your logarithmic goes to your value of your exponential. Your value of your logarithmic goes into your exponent. So if you can see that right off the bat, you can go right into it. If you have to write down your coordinates, I'm okay with that too. They're both the same. This, if you do it, just go straight into the other one. You just have to be a little bit more careful, okay? I don't know. Okay, so these ones, they don't give us a value, so we have to find in our calculator. So you can just go right into your calculator and go log of, so if it's log of 4 base 2, you would just put this, go log of 4 divided by log of 2. Press enter and it'll give us 2. Does everyone get 2? So let's put this in exponential form. So our argument for our log is our y value. So our argument for this one is what? 4. Equals, and then yeah, our base stays the same. So our base is 2. And then our exponent was our value. So it'll be 2 squared. You can do it into your calculator because you know that 2 squared equals 4, so you know that that's also true, okay? Okay, so I'm going to color code this. So this 4 goes here. This 2. So your bases will stay the same. And then this black 2 will go to your exponent. Do you see what I did? I don't know. I don't know. I'm not going to worry about it. Okay, let's do this next one. Log of 2 base 2. Give me an answer. Give me a value for that. So it'll be log of 2 divided by log of 2, which it should be what? And if you divide anything by itself, it should be 1. Okay, so log of 2 base 2 is equal to 1. Let's write that exponentially. So our argument always goes to the value. So our argument of our logarithm always goes to the value of our exponential. So what will be our number over here? 2 equals? Yep. Yep, 2 to the 1. You know that 2 to the exponent of 1 is equal to 2. So you know that 2 equals 2. You know that that is correct. You don't have to put the 1 up there if you don't want to. What is log of 1 base 2 equal to? Put in your calculator. Don't just guess.
Well,
What is it?
I guessed to 0 and everything didn't end right.
So I have log of 1 base 2 is equal to 0. How do we write this in exponential form? Perfect. 2 to the 0 in your calculator is equal to 1. Anything to the exponent 0 is equal to 1. That's true. Okay, log of 1/8 base 2. What is that value? So you go log of 1/8. I'll show you in your calculator. I'll do this one with you. So go log of 1 divided by 8. Close your bracket. Divided by log of 2. -3. Perfect.
Where did you get the 1/8 from? Like, is this part
Oh, these are just random examples for us to work with.
I thought it was like expanded from the.
No, these are just showing you that as soon as you have this argument that is between 0 and 1, this will be negative value. Okay. So they've already done this for us. The argument was 1/8, so that is our new value. Our value was -3, so that was our new exponent. Okay, so now let's go the other way. So log, what's our base still? Our base is still 2 here because our base is 2 there. Do I put 1/4 and -2 here? 1/4 equals -2. Perfect. Okay, this next one, log, what's my base? 2, what's my argument? 1/2 equals -1. Perfect. Any questions with how we did any of this, guys? No? Okay. Okay, we're going to write this in logarithmic form right now. Okay, so we know that y equals, let's go just b to the x, and then y equals log of x base b. Okay, so knowing that, do you want me to just put in an example so you can see it? So if I had 2 squared equals 4, this was the same as log base 2 of 4 equals 2. Okay, this is a really easy one to write down as an example, like on a test, because you know that 2 squared is equal to 4, right? 2 times 2 is 4. Oh, this might not be a good example because the 2's might confuse you. Just as long as you know that the bases will always stay the same. This exponent will turn into this value turns into this argument. Okay, so I know that these two, I'll put these into colors. The 4's, that goes there. And then, okay, so just know those are the ones you're switching. Okay, so 10 cubed equals 1,000. How do we write this in logarithmic form? So log, what's my base? 10. You don't necessarily have to write 10, but we'll just do it here for the example, okay? What is my argument going to be? 1,000 equals to 3. You can always do a check with these ones, so just go log of 1,000 divided by log of 10. Or since it's base of 10, you could just do log of 1,000. Enter. 3. Okay, so you can always check your work on these ones. If they are variables, just throw in random numbers. So if it's x and y, just make up an x, make up a y. It should be consistent. Okay, 3 to 6 1 4 equals 81. So log, what's my base? 3, what's my argument? 81 equals what? Good. Go the other way. Always look for your base first. What's my base here? 5. What's my new exponent? Equals 625. Do you check in your calculator if you want to? 5 to 6 1 4. Oh, it should be equal to 625. Okay. What's my base if there's no base? 10. That's my exponent. 2. What is my value? 100. I think you guys are catching on. Logarithmic equation can be expressed in exponential form as x equals b to the y, because if we have exponential function, all we're doing is switching your x and our y. So you can also write it like that, but we can't graph that because we don't know what y equals, so that's why we use log. Okay, so this is what we talked about a little bit last unit. Same thing, if you have y equals b to the x, you can express it as log of y base b equals x. So all you're doing here is equal to this, because all you're doing is switching your x and your y, or just leaving them the same. Okay, so these are actually equal to each other. So this is equal to this. This one's equal to this one. But we're not going to use those, okay? Did you say how? Is that what did you ask how, Michaela? No? Oh, okay, sorry. Okay, so let's put these all into exponential form. So what's my base? What's my exponent? Equals x. Good. What's my base? 10. What's my exponent? Equals? Good. What's my base? What's my exponent? Equals? What's my base? Equals B. Okay, so let's go the opposite way. Log, what's my base? 4. What's my argument? 64 equals? Good. So this just takes a lot of practice to get used to what goes where, okay? So log, what's my base? What's my argument? Equals? If my base is E, can I rewrite this with using a different? Yeah, natural log. Natural log, do I have to write the E here? No. So I'll put it both ways. So you can go log base E or natural log, they're both the same. What's my argument? Equals to what? So both of those are the same. So if you go log of f base E equals D, if I ever have a log base E, you can write it as natural log, okay? Okay, we're going to put these exponential and then solve for the variable. So do exactly what we did before. What's our base here? 6. What's our exponent?
4.
What's it equal to? Can we solve 6 to exponent 4? Put it right into your calculator. Oh, you're just ahead of the game. Did I do that right? Is that what you said? 296? Okay, good. Okay, I want you guys to do these next 3 on your own. I think you've got this. So I'll give you a few minutes. So, yeah, so this one you're solving for B, you're solving for B, you're solving for Y. You know how to do this one? Did you figure it out? Okay, I'll just do this one. If you got it, that's fine. What's my base? Your base is B. What's your exponent? Equals. Okay, so to solve for B here, you just do the opposite. So if B is being squared, the opposite would be to take the square root. Do you understand how to do that? Yeah? Okay. Do you remember how to do this one?
Oh, you're making a negative, right?
No. You don't make it a negative unless it's on the bottom. But make it to the reciprocal. Okay? So this is the same as B to the 3/2 all to the 2/3 equals 125 to the 2/3. We kind of did this that first unit, or first lesson. Because 3/2 times 2/3, if they're reciprocals, meaning that the numerators and denominators are opposite each other, those will multiply to be 1. So B is equal to 125 to 2/3. Put 2/3 in brackets. 125 exponent 2 over 3. Does that make sense? Do you remember that from last week? No, kind of. Maybe not. I'll just do another example of. Yeah. So if I have, let's just, for example, x to 3/4 equals, I don't know, 100. This isn't going to be a pretty number, but this is just for example. To get x isolated, you want you want to get this 3/4, you want to get that exponent to be 1. Okay? I know that 3/4 times 4/3 equals 1 because the reciprocal, a number times its reciprocal will always be 1. Okay? So I want to put these both then to exponent 4/3. What I do to one side, I have to do the other because 4/3 times 3/4 equals 1. So this is just x equals and then 10 to the, or 100 to the 4/3. Does that make sense now? Okay. Just put this into your calculator. Log of 6. We don't have to put this. Okay, it says as an exponential equation to solve for the variable. Can you just, oh, it wants us to solve the exponential equation. Okay, what's our base? Okay, 6 to the y equals 6. Your y is going to be the same no matter what, though, right? Whether it's the inverse or not, right? Because no matter what you do with your y, can't you just solve for 6 to the y squared? I would have just solved for, just wait. You could just kind of look at this one and see, how do you get from 36 to 6? What do you say? Square root. Can I put the square root as a fraction? So the square root of x is the same as x to the 1/2, right? So if you want to just look at this one, what? Yeah, y equals 1/2. Because I know that 36 to the 1/2, or the square root of 36 equals 6, right? I would just do one of this, like guess and test. Okay, they're not going to ask you something crazy like that. If they do on the diploma, put the answers into y. Okay, so on the diploma, if they have a question like this, and you don't know how to get the y, do this, and put A into y and see if it works. Put B into y and see if it works, okay? That's what I would do on the diploma for this type of question. If you can't see right off the bat that the square root of 36 is equal to 6, that's what I would do. Okay? Because no one's semesterized anymore. Okay, so let's finish this off quick and then have a work period. So by converting from log form to exponential form, calculate the value of t. Okay, so let's put these both into exponential form. So we have to figure out what x is to be able to put into the second one to figure out t. So this is just a two-step process. So let's look at this first one. Log of x base 2 equals 3. How do we put that in exponential form? So what is x going to be? What? Yeah, 8. So I'm just going to put 8 right over top of this. So if x equals 8, so now I have log of t base 2 equals 8. How do I write that in exponential form? So what is t equal to? 256? Good, thank you. Do it for the second one. Same idea. The first step will be the same. The second step will be a little bit different. Try to figure it out. X equals 25. Is that what you got? So then you get log. Do you square root it? Oh, just wait. Let me get there first. So t is to negative 2 equals 25. Are you there? Okay, so do you get something like this? If you're what you're looking for is your base. Try to multiply or put that exponent to get this equal to 1. What do I have to multiply by negative 2 to equal 1? Negative 2 times 2 is 4. Always multiply by the reciprocal. So negative 2 is over 1, right? So multiply this by negative 1 half. Okay, so negative 2 over 1 times negative 1 half is equal to 1. So I want this new exponent to be negative 1 half. Do you guys see what I'm doing here? So if you ever have the base as the variable, always set that exponent to multiply the other exponent to get 1. Sorry, what are you guys asking? Yep. So then this will be t equals, and then 25 to the negative 1 half. You can put that into your calculator. It's a negative, so it's going to be a fraction. 1 over 5. Okay, so 25 exponent, and then brackets negative 1 divided by negative 2 bracket. Oh, go press math, and then enter, enter. Yeah, so if you press math, that first one is it says FRAC, and then that's just how you put it into a fraction. Any questions so far, grade 12s? You good? Alrighty. Almost done. Okay, so it's just saying what we've already done. The logarithmic form of y equals a times b to the x, or y over a equals b to the x. So this is now just throwing in an a value. So if I have my a value, my constant number, I can divide both sides by a. So y divided by a is equal to b to the x. Is everyone okay with that? So all I did was divide by a. So then, if I ever have this, always put your a value. If you ever have an a value for exponential form, to put it in logarithmic, always divide by your a value. So you're going to use this to make your new log form. Okay? So your base is still going to be the same. So your base will be b. And then your x will be here. Where's a y over it this way? It's a y over a, isn't it? Log of b. I'm confusing myself right now. Log of x. So this goes outside. Oh, is it x? That's right. No. Y equals b to the x. Y equals a times b to the x. That's right. These ones are the same. The b stays, the y goes inside. The y goes inside here. So this whole thing, y divided by a, goes inside. What? Sorry if I messed you up. Okay, so knowing that, the first step we're going to do is we're going to divide by a. So this has 2, so we're dividing both sides by 2. So log, what's my base? Three. What's my argument? Y over 2 equals just x. Your 3 is your base. Because 2 is your a value.
Okay, that makes sense.
What are we going to divide on this next one? 7. What's my base? 4 is your base. What is your argument? 8 over 7 is equal to? Good. You guys tell me what's right for this next one. What am I doing first?
Log of S or log S.
Divide first.
Oh, well, you divide by R.
Yeah, divide by r. Log of I got it. Excellent. I have no idea. I can check. Yeah, so first divide by a. And then just do exactly what you did before. Okay? So now let's go the opposite way, except we're going to have to multiply by the end. Okay? So what's my base? 7. What's my exponent? Equals y over 3. So can I isolate my y?
Times by 3.
Multiply both sides by 3. So this actually goes to 3 times 7 to the x equals y. You see what I did there? All right, so multiply both sides by 3.
Oh, yeah. Okay. Oh,
Okay, it's next one. What's my base?
why didn't you just put,
Why didn't you just leave it here? Is that what you're asking?
no, never mind. Like, why didn't you multiply the 3 times 7? Yeah.
I did.
But why didn't you write the actual,
Oh,
are you not supposed to? Or?
no, because x is an exponent of 7. So if I multiply the 3 and the 7 to make 21 to the exponent x, it's going to throw everything off. Okay? X to the exponent of 7 is a different term than 3. We're writing in the form y equals a times b to the x. We never multiply the a and the b. Okay, so this is how you leave it. Good question. Okay, 5. Oh, sorry. I was going to ask what the base is, and I said 5. So 5 is my base. What's my exponent? What is it equal to? Yep. How do I isolate y? Divide by 7. So 5 to the x over 7 equals y. What's my base in C? E. What's my exponent? Equals. So how am I isolating y? Yep. Good job, guys.